We're moving on to Chapter 6, where we're going to talk about the overview of Windows Server clusters. So failover clustering is something that's been out now for several versions of Windows Server, and it's a group of these independent computers, and they're going to work together. Now, we rename servers to nodes, so sometimes I'll just call them server nodes just so you don't forget. But basically, a node is a server that's inside a cluster, and when you have multiple different nodes, then you have high availability, and you have scalability and the ability to fail over. Failover clusters provide something called a cluster shared volume, and that's going to be that shared space that the various different nodes are going to use for accessing the cluster. So a quorum is part of a cluster, and that's the majority of voting nodes. So what happens is if you have, say, an even amount of server nodes, let's say you have 4 server nodes, and they can't decide as to who's in charge of providing an application to a client that's connecting into the cluster, then you have this cluster quorum, which is going to use what's called a witness. And a witness can be several different things: a disk, a file share, you can use an Azure Cloud witness, and it's going to break the tie. So each of the server nodes have their own vote. They each get 1 vote. But if it's 2 to 2, then you end up with a real problem. So you end up having this witness that will then vote, and then that will create a majority in the quorum. And then you can say, okay, 2 are voting for one, 2 are voting for another to provide DHCP services. And so the witness will come in and will make the decision that will break the tie. So it prevents those 2 or more nodes from concurrently operating as a failover resource. So you don't want to have more than one server that's trying to offer the same service to the clients, because then neither of the server nodes will provide that server, because the client will be confused as to who's providing it. So if you're sitting at a restaurant and 2 different chefs come to you with a pizza, the exact same pizza, and you're not sure which one to take it from, then you need somebody else to walk up and say, okay, this is the pizza that's going to be better for you. Here, you go ahead and take that one. And that's a little bit the way it works. Now, if you have an odd number of server nodes, then a witness may not be necessary. A witness doesn't usually cause any problems. It's there to solve problems, but you can decide whether or not you need one. It's not something that is mandatory. So the cluster itself can calculate the number of required votes for that service. So if more than one server, for instance, provides DHCP services, then the cluster is going to decide which one is going to provide that service to the clients. In Windows Server 2019, there have been some good improvements to clustering, such as performance history, so you can get a good idea if the cluster has had any problems and what those problems were. You've got Windows Server System Insights as well, that gives you some predictive analysis of what's happening with your cluster. Another nice thing you can do is you can do an in-place upgrade of cluster nodes. And that allows you 4 different options of doing that upgrade. And some of them include some downtime and others don't, but they end up taking longer to do the upgrade. So you can choose which way you want to upgrade your cluster nodes when, say, an operating system upgrade happens. Another improvement is going to be it's no longer using NTLM for authentication, because NTLM is no longer considered secure. It's using Kerberos now instead. And there's some improvements to scale-out file servers. Scale-out file servers is an interesting way of making a file server available to your clients for accessing shared folders and files. In a traditional cluster file share, what would happen is let's say you have 2 nodes, server A and server B. So if server A is the one that's in charge of file sharing for the clients to access shared folders and files, then what's going to happen is let's say it's the G drive. So you put all your shared files on the G drive, which is a shared piece of storage on another device, like a storage area network device. Then if that server A goes down, server B is going to be in charge of it. And so what's going to happen is the G drive will disappear off of server A and magically appear on server B, and it will serve the clients. And they use what's called a shared name. So the clients are still going to connect to cluster.widgetllc.internal, for instance, to which both of the server nodes will respond. So if server A goes down, server B will respond to the same name. Now, a scale-out file server is a little bit different. Instead of either the server A or server B responding, it could be either server. So what happens is the storage ends up going in the C drive on a special folder that's called cluster storage. And that cluster storage folder is then going to be where both servers access these shared folders, and either one of them can do it at the same time. So instead of one server providing access to the shared folders, either server can do it. So if one server is really busy, the other server takes over, even though they're both up and running at the same time. And you can see there's some other improvements as well, such as Azure Awareness. Clustering has changed when it comes to networking. Networking in older versions of clustering required a dedicated IP address for your cluster name. And now, instead of using a dedicated IP address that both servers or all the server nodes respond to, it uses the IP addresses of the servers themselves. So what it does is it creates DNS entries for all the servers using that same example name of cluster.widgetllc.internal. So all the different IP addresses are available. So what would happen before in the previous version was sometimes the cluster IP address would become unreachable for some reason due to some technical issue. But now, since the cluster name is tied to all the different servers' actual IP addresses, then that issue goes completely away. There's lots of different services you can make available for clustering technology. So it's important to decide which ones you want to make highly available and which ones you want to install on which server node. So for instance, in the case of DHCP, let's say we had 10 servers. Well, you have to install the DHCP server role on all the different servers that are going to be providing DHCP service. And you may not want to install that on all 10 of them. Maybe you just want to make 3 of them DHCP servers instead of all 10. So that way, if one fails, then the other one can provide the IP addresses, and you can do that with up to 3 of them. There are 2 different ways we can make servers available in case there's a problem. There is high availability, and there is failover. Failover refers to a single server providing a service, and when that server goes down, another server provides it instead. High availability says, hey, multiple different servers can all provide the same server at the same time. Some services are being used as failover in Windows clustering, while other services are going to be used as high availability. And you can see here that availability refers to a level of service. And a lot of times when we provide service to a client, we'll say that you're going to get a certain level of service, a certain response time, a service level agreement. And clustering has the same kind of thing. What Microsoft is saying is that you're going to get better than 99% availability. And then that's what you can go ahead and tell your customers that are connecting to those services. Failover clustering is great for stateful applications where they're restricted to a single set of data. So you could use, for instance, a database as an example for your application. The database is going to be installed in just one location. So you put that into the shared storage location that both or all your server nodes can all access simultaneously. And then you can make that available by adding that as an option into clustering and saying which servers it's installed on. Although the database itself is on the shared storage, you still have to install the application to run the SQL database on all of the individual server nodes that you want to provide to your clients. You're going to need to make sure that each of your nodes in your cluster are going to have the capacity to handle having an application fail over to them when a server node goes down and that other server needs to provide 100% of the service. So if you end up with one server that's super powerful and one that's not powerful enough, and you end up having all the services fail over to the weaker server, then you could cause that server to crash as well. So make sure that you have enough resources on all your server nodes to keep that from happening. It's recommended that you have hardware with similar capacity for all the nodes. You don't have to use the same brand of server or the same type of RAM, same type of storage on the C drive, for instance. The storage that's shared between the server, that's what they both access using, say, an iSCSI connection. But the storage on the C drive, that's going to be individual to each server. So Microsoft is recommending that you do use similar servers with similar capacities when you set up a cluster, but you really don't have to. Hardware components should be examined to make sure any single points of failure. You can fix single points of failures by adding additional storage controllers, adding stripe disks, such as in a RAID 5, RAID 6, that kind of thing. Teaming up network adapters. So you can create multiple, you can take multiple network adapters and create a single adapter out of there for high availability and failover. And you'll be doing that in one of your upcoming labs. Now, if you buy a storage area network, those devices are designed to connect as iSCSI connections typically, although there's other types of connections as well besides IP-based iSCSI. It's just that's the most popular and the one that you should learn. Those devices typically have all types of redundancies built into them. For instance, they'll have a RAID configuration. They'll have redundant power. They'll have redundant networking. And they do it using what's called canisters. So if you look at the back of a SAN device, you can see that there's a whole bunch of different modules with handles on them. So if, for instance, the network canister fails on the left side of the SAN, you can have all the networking fail over to the right side, and then you can pull the canister out of the left side, replace it, and then you can go back to load balancing between the two. Although not all the hardware has to be identical, the network adapters should be identical. Otherwise, you could end up with all kinds of problems. So when you fail over from one to the other, it's important that they both use the same network driver and the same version of the network driver. I've actually used a system, a clustering system, that did not have the right network driver on it, and it caused the cluster to fail randomly every few days. Very frustrating. So once I got the correct driver from Microsoft or IBM or whoever it was, then the crashes stopped happening. So you want to make sure that you're using the same network card drivers and that they are both on the same version of your driver software. And also, it's recommending you use the same type of addressing. You can either use static or dynamic, but make sure that both your server nodes or all your server nodes are using the same thing. Otherwise, you'll cause problems. Windows Server supports multiple domain clusters and workgroup clusters. So you can create a cluster, you can add a server or multiple server nodes to those clusters, and you can add a second cluster and a third cluster if you'd like, using different server nodes. Now, a server node cannot be a member of more than one cluster at a time. However, you can have multiple clusters running on your server. Basically, you would just connect to these different servers in these different locations, but manage them from all one location. And the way I've done this is for disaster recovery. So I've had clusters fail, even though the servers themselves were perfectly fine. And so what I had to do was I had to create a second cluster on that server and move all the server nodes from one cluster to the other, and then delete the original cluster that was failing. And that allowed me to get everything back up and running again. So creating a failover cluster is fairly easy. It does require some testing to make sure it's going to run properly, but you want to make sure all the servers that are going to function as nodes, they have to run the same version of Windows Server. So whatever version you're using, make sure it's the same version of Windows Server, and all the updates are updated to the same level. You don't want to have some server nodes that have a higher or lower amount of updates compared to the others. You want to make sure that all hardware and software requirements are met, and then you're going to need to add the failover clustering feature. So whether configuring your brand new cluster or maintaining an existing one, a great thing to do is to use the Validate Configuration Wizard tool. And so what that's going to do is it's going to go, after you create your cluster, it's going to go through the cluster, all the different components of it, and it's going to make sure that they all pass. Now, if they don't pass, it'll tell you what's wrong, and it'll give you suggestions on how to fix it, which is a great feature. So you want to make sure you have that in there. Otherwise, your cluster either may not be allowed to be created, or even if it is allowed, it may not function optimally. So a green check mark during the tool when it's being run means that everything's good. The yellow yield sign will allow you to create the cluster, but it will give you a warning. And then the red circle will stop you from creating that cluster. In some cases, I've noticed that the yellow yield sign basically is not an important thing. It just depends on what the warning is. You can look it up online at Microsoft.com and find out if that's an important warning sign or not. You also want to run the cluster, the validation test on the cluster, if something gets changed or updated. So maybe if you go from Windows 2016 to 2019 or 2019 to 2022, anything gets changed, you want to run the validation tests again to see if you missed anything that may cause a problem after you put everything back online. You've got to have shared storage available. So as I mentioned before, you can use a SAN device, and you can connect that using what's called iSCSI. You can also connect it using what's called SAS, or Serial Attached Storage. SAS is not as fast as iSCSI is, but you can use it. In some cases, it's a little simpler to set up, but it's not going to max out at the speed that iSCSI can handle. Now, there was a time when SAS was actually faster than iSCSI, but more recently, that's no longer the case. iSCSI is simply a way of connecting your server nodes to your SAN device using an Ethernet cable. Now, you can certainly connect to a switch, all your devices to a switch that's being shared using various different computers and servers on the network. I don't recommend it. And that's because it may end up using up all the bandwidth on that switch since it uses these jumbo packets. Jumbo packets keep the data packets from being split up into smaller packets where they have to be reassembled again if you use the smaller packets, like the default 1500 byte size. So by using jumbo packets, you make the connection to your SAN device using iSCSI much faster. But if you're using a shared switch, then you could end up slowing everybody down. So what I typically would do is I would connect my server nodes to either a separate switch that nobody else is using or just directly into the back of the storage area network device, depending on if I had enough network connections based on how many server nodes I have. If I didn't have enough connections, then I would need a switch. You could also use fiber channel as well. So instead of using iSCSI, you could use fiber channel. And then there's another type called fiber channel over Ethernet. So basically it uses fiber cables, which means that you can get super fast connectivity, 10 gigabit, 40 gigabit, that kind of thing. But you end up using IP addressing instead of the fiber channel protocols, which are completely different from IP addressing. So this fiber channel over Ethernet gives you the speed of fiber, which is way better than Ethernet cables, but it also gives you the IP addressing that iSCSI uses for simplicity. You need to create failover networking for this to be officially supported by Microsoft. So what that basically means is you must pass all the validation tests during the creation of the cluster in order for it to say it's now a Windows cluster. In Windows Server 2019, you can now move a cluster from one Active Directory domain to another one without destroying the cluster. This is a really nice feature that allows you to move from one location to another when needed. Now, I've never had to move from one domain to another, but it's a nice feature to have in case you ever come across that, say, during a merger or acquisition. The cluster is going to have a shared name, what they call a distributed network name, but it's just a shared name that all the different server nodes will respond to. So that way, if one server node goes down, then the other server nodes will continue to service the clients using that same name. After your cluster is in production, you want to make sure that you have it backed up properly. And a lot of third-party applications that run backups, such as Backup Exec and Veeam and other ones, they are cluster aware. So they can see that cluster in the backup application, and they can back up the cluster portion, which requires a certain amount of files that are on the server nodes, and it will back those up properly. So in case you ever had to restore the cluster portion as well as the data on the cluster, then you can do both, either to the same server or to a new one if needed. When you double click on any of the applications in a cluster, then it's going to give you the option to change the preferred owners and the failback settings. So the preferred owner basically means, let's say you have server 1 and server 2, and server 1 goes down, but it's really the server that you want to have this application on for whatever reason. So once server 1 comes back, then you're going to use the failback settings to automatically fail back the application to server 1, so it's not running on server 2. A nice feature to have, especially if you have one server much stronger than the other, but otherwise not as useful if they end up being exactly the same. Stretch clusters are really interesting. It's a great feature to have because it allows you to have a cluster separated by multiple different locations. So prior to supporting stretch clusters, if you had too slow of a response between server node A and server node B, then they would both think that there was a problem because there's what's called a heartbeat connection between the different server nodes. Server node A is constantly pinging server node B and asking if it's alive. And server node B is doing the same thing to A. So if the response time got too slow because server node A and B were separated by a long location distance and connected, say, through a VPN tunnel that wasn't as fast, then you could end up having where they both are trying to fail over to themselves. And you don't want that. So by adding in stretch clusters, they increase the timeout period. So you can end up having a much longer time between the two heartbeats that go back and forth based on the speed that you're connecting on. So that allows it so you can have your cluster stretched over multiple locations. Storage replica allows you to have a SAN device replicate to another SAN device, whether it's local to the same location or someplace else. So if your original SAN device fails or there's a natural disaster of some kind, then you'll be able to continue running using your replicated data. You can configure the stretch cluster using Failover Cluster Manager or using Windows PowerShell. You can also create a quorum the same way for a stretch cluster that you can use for a standard cluster. But I recommend, if you're going to use a stretch cluster, to use the Azure witness, because that way it's both the same amount of distance to Azure from both locations. Whereas if you use, say, a disk witness, then you could have a problem where one server will connect to it much faster than the other, and that one server node will end up getting the vote information sooner than the other, which could cause a problem as to deciding who is in charge. In this chapter module, we learned all about failover clustering, quorums, features, improvements, and other great information about Windows clustering. And that will conclude our Chapter 6 module.